Welcome back to MPT. Today we will describe 3 critically important filters that are commonly used in communication and radar systems. Without these filter types, many modern systems would be difficult to produce.
Get your product to market faster with a custom phased array solution from MPT Corp.
Your first question may be, well, what is a filter? A filter is an electrical component that is used to select or reject a portion of the radio frequency spectrum. Filters are often used to protect the electronics in these systems from undesired signals. A filter may be best described by using an example. Let's say that you're developing a ground terminal for a Ku-band satellite system. For the receive portion, you only want to pass the desired signals from the satellite. Also, let's say that you know the satellite downlink frequencies are 11.7 to 12.2 gigahertz. For your system design, you only want to pass signals that are of the desired frequency range, and you want to keep out all other signals from your electronics. The component that performs that function is called a filter. The illustration shows the frequency response of a nearly ideal filter showing the highly selective range for out-of-band signals. The image of the ideal filter may have sparked a question in your mind about the shape of the filter response. The next image shows the filter response changing as the complexity of the filter increases. Note that the rejection slope of the filter increases as the complexity of the filter increases. Generally speaking, more complex filters have better rejection of undesired frequencies. As you can see, the filter designer must make choices between complexity of the filter and the filter's rejection slope performance. This brings us to the first important type of filter, which is the lumped element filter. Lumped element filter construction uses discrete inductor and capacitor and resistor components. The image shows a lumped element filter that MPT developed several years ago for a phased array radar system. It's the anti-aliasing filter for the system. The measured performance plots show that the filter has good rejection slope and reasonably flat frequency response in the desired bandwidth. Some benefits of a lumped element filter are their low cost and small size. Some drawbacks are the performance and repeatability depend upon the tolerances of the inductors, capacitors, and resistance of the lumped elements that are used. The second essential type of filter is the planar transmission line filter. This type may be the favorite filter for the engineers here at MPT. In fact, our engineers have developed numerous types of planar filters. While there are many types of transmission line filters that we could be focusing on in our discussion, we've settled on the edge-coupled bandpass filter since it's so often used. The image shows an example of an edge-coupled bandpass filter used in one of our low-noise block products in a communications phased array. The measured performance plot shows that this type of filter can provide reasonable passband performance and rejection slope. The main drawbacks of this filter type are its performance dependence upon the accuracy of the circuit board fabrication and on the substrate material that's being used. Specifically, the line width and gaps must be very tightly controlled, and also the exactness of the manufacturer's process for the metal is very important. In addition, the tolerance on the dielectric constant of the substrate material and the tolerance on the substrate thickness affect the filter's performance. The main benefit of this filter is that if careful design is carried out, you can actually create a design that is repeatable and very low cost. The third type of filter we consider here is the waveguide filter. MPT uses waveguide filters in some of its products when very high performance is required. The image shows a waveguide bandpass filter used by MPT in one of its recent test and measurement products. Waveguide filters have the distinct advantage of providing low insertion loss and very high rejection slope for undesired signals. The main disadvantage of waveguide filters are their large size and that they weigh quite a bit. Satellites traditionally use waveguide filters for the channelization multiplexers due to the excellent performance they provide. They've also been used in wireless systems to provide isolation between transmit and receive functions. In this video, we've described 3 essential filter types for communication and radar systems. Of course, there are many other types of filters that we could have described, and we may talk about them in another video. If you're in the market for a phased array or other type of antenna solution, then consider the experts here at MPT. Until next time, this is Rick Sturdivant with MPT.